So the last part of the 2018 paper 1 has some great questions in it. The rates and bands for income tax are as follows. Pretty much guaranteed an income tax question you can be sure of most years, or definitely an interest-based question. Lorna has a gross income of 50,000 for the year. Using the rates and bands above, work out her total income tax for the year. No mention of tax credits in this question till part C. 35,000 at 20%. You can see here 15 minutes, take your time. 35,000 by 0.20. Check it twice on your calculator. Or just divide 35,000 by 5. A fifth is 7,000. The balance, write the income here, 50 is written here for us, 50. So 35 and 15 is 50. You could write 50 minus 35 somewhere if you wanted. 0.40, so 40%. 10% is 1,500. Multiply that by 4. You're going to get 6,000 on your calculator. Check it twice. Add these together. Check them twice as well. 13,000 is our total income tax. Write that down here. Total income tax. You give yourself more room than me. So complete the graph on the next page. Take your time at graphs. You can see here 15 minutes showing the amount of income tax for every gross income up to 60. Slightly different than the 50, be careful. And then the amount of income tax shown. So we're given up to 10,000. So let's see what they're looking for here. So we're given the start of a linear graph. We're given the point 10,000, 2,000. Just write that down. 10,000, 2,000. Where does that come from? 10,000 by the 0.20 is your 2,000. So up to 35,000 we know is the cutoff. So 35,000, the point will be 35,000, 7,000. We've already worked that out above. So go to 7,000. 35,000. Put your ruler on both and just double check. And it looks like it's about there. You have a ruler. You're not going to have a wobbly line like me. You can make this nice and big and label it if you want. Don't need to though. We have it here. 35,000, 7,000. Just double check it again. And where does this graph now changes? We have a different tax rates. So the next band I want is 60,000. So what's going on there? It's an extra how much? From 35 to 65, an extra 25. It was 15. 25 by the 40%. Just going to put the decimal in here. Will be 2,500 by 4. An extra 10,000. So we currently have 7,000. So we're going to have 7 and 10. 10 plus 7, 17,000. When we have 60,000 of income, we'll have 17,000 of tax. Kind of clue given on the scale of the graph, so it's up here. So this line just changes slope, going from there to there. And then in the last part of this question, we're asked to, if everyone gets a tax credit of 3,000, draw a graph to show the amount of income tax to be paid from 15 to 60 every year. Just change colors for this one. So let's figure out what's going on here. If we have a tax credit of 3,000, how much would we need to earn? 15,000 divided by 5 is 3,000, so 15 by 20% is 3,000. So we'd have to earn more than 15, which is here, to start paying tax. And you can see here that that will be 3,000 there. So we're paying 3,000 less, so it'll be the same up here. We were paying 7,000, we'll be paying 4. So that's the start of that graph. 35,000, 4,000. 3 less. And then obviously the next one will be 3 less than 17 will be 14,000. Put your ruler on and join these together in a better effort than me. Give it one more go. A little bit better. And you can see here these are the two graphs that they wanted. And there were 30 marks in total for this question, 5 for C, 15 for A, where you just worked out the 13,000, and 10 for B. So 10% of the overall paper, nice and easy. You had 15 minutes, so take your time. You have loads of time in the exam. Question 11 is your knowledge of inequalities. Write down an inequality in X represented by each of the number lines. And you know, when we deal with natural numbers, we put dots. When we deal with Z integers, we put dots. And when we deal with real numbers, we colour in the line. And we either put a circle and colour it in, or a circle and don't colour it in, depending on the less than or equal to or just less than. So that's what we're dealing with in inequalities. So immediately we can see with the first one, it's real numbers. It's actually given to us. The second one is going to be, well, into the minuses, so it has to be integers straight away. The third one is just 1, 2, and 3. So that is going to be dealing with natural numbers. And the last one, again, coloured in, is going to be real numbers. And we can see here, neither of the dots are coloured in. So let's just have a look at the range of values here that we're asked to fill in with the first one given to us. The dots coloured in, so we have less than or equal to. The one on the left coloured in, the one on the right is not coloured in, so we just have less than. Let's do the next one. So we have integers. So X less than. Two options here. We could, let's put both options, less than or equal to. So for the first one, X has to be less than 2, so it can't be 2, and it has to be greater than -4. Can't be -4, so that would work. And then the second possible solution, we could make them 1 and -3, the values that are given. So these two will work for us. There are 10 marks for this question in total, so a lot to fill in here. Probably about 2 marks for each, pretty much. So this one here, natural numbers, X less than if you want. So it's going to be less than 4 or less than or equal to 3. And it has to be greater than 0. And then X would fit between 1, 2, and 3, would fit between 0 and 4. And the last one, X just less than on this side, 4 is the number because it's not coloured in. And on the left hand side, -2, and it's not coloured in, so just less than. So good knowledge of inequalities, pretty much a giveaway 10 marks here for all you smarty pantses. Going from inequalities to algebraic fractions, all these classic questions that are going to come up at junior cert. If you follow my method, you're just going to write down the bottom 2 terms, the denominators, multiply them, and then we're going to set it up to cross multiply. So we're going to have 2 by 2n plus 5, and then -5 by n minus 3. So we're not worried about the letters or what they are. We just set the fraction up always the exact same way, and then we multiply it out. Top line becomes 4n plus 10 minus 5n plus 15. The bottom line, now there's 2 options here. We could multiply it out, but if we can multiply it out, we're asked to write it in its simplest form. If we multiply it out, we can also factorize it. So I think its simplest form is this. So 4n minus 5n minus n. 4n minus 5n. And then 10 plus 15, just take them off as you go, plus 25 over n minus 3 over 2n plus 5. If you multiplied it out, they would give you full marks, but you don't have to. No point in making a mistake when we don't have to do the work. So 15 marks for an easy enough algebraic fraction. 12b, you're asked to show that 4x minus 3 squared plus 24x is positive. We're told that x is an element of real numbers, so it could be negative. So the key here is to show that something squared is greater than 0, and that should help us here. That will make it positive. So we got to multiply out this bracket and see what happens. We're going to get 16, square the first term, 16x squared. 4x by minus 3 is minus 12x twice, minus 24x. And then minus 3 by minus 3 is plus 9. You can write out the bracket 4x minus 3. You know you have enough time to do this in an exam, so this is why we teach it this way in class. So you don't have to rush. Unless you're 100% confident, don't do what I do, because it does lead to mistakes. multiply out your brackets that way, or if you wish to separate them, 4x by 4x minus 3 minus 3 by 4x minus 3. There is no bonus marks for doing it either one of these three ways. You all will get to the same conclusion. So there's many different ways to drive home. There's many different ways to do these questions. So we also have to add in the 24x. Don't get distracted either like me during an exam. 24x and minus 24x cancel, and we're left with 16x squared. There's our squared part, plus 9. Is this greater than 0? Well, what we can say is anything squared, x squared is greater than 0. Therefore, 16x squared is greater than 0. Therefore, 16x squared plus 9. Because 9 is positive, has to be greater than 0. Quad or rat demonstrandum, that which has to be demonstrated. You have done it in spades here. Move on to question 13. So question 13 requires a brilliant knowledge of sets, because we're given these statements. We're told to just tick one box. Read the question carefully. Just one box. Put a tick in the correct box in each case to show whether each statement is always, you can see here, don't mix them up, sometimes or never. Sometimes or never in these boxes in reverse order. And we're told here, just in case you've forgotten, P complement, P apostrophe, P complement is the complement to set P, which is, as you know, you're saying to yourself, everything outside set P. So we're going to need that at some point. So part B of this question is actually just to prove one of these things. So if you did manage to guess them, you actually have to prove them. What we're going to do here is we're going to look at all four and prove them all. So let's set up two scenarios for parts 1 and 2 and 3 and 4. Starting with 1, P union Q. I'm going to write it out again. The number of elements in P union Q, just to double check my reading is correct, is equal to the number of elements in P. And you're showing the examiner what you're doing, plus the number of elements in Q. So let's do scenario 1 here. Let's see what happens. Okay, is this always, sometimes, or never true? Okay, let's put one element, let's label them P and Q. Let's put an element here and here. So the number in P is equal to 1, the number in Q is equal to 1. We're just setting up the simplest scenario possible. Therefore, that's true. That statement is true because the union is equal to 2 and these two added together is equal to 2. Just not to write that out. So now scenario 2. What could happen in these questions? It's always the intersection we're really focusing on. Now, how many elements are in P? Number of elements in P is 2 elements. They have one in common, but the number of elements in Q is also 2. Now, is this statement true? Well, what about the union? The number in P union Q is equal to 3, as you can see, but the number in P plus the number in Q is equal to 4. So therefore, that's not always true. It's definitely never true, so it's just sometimes true. Okay, let's look at scenario 2. So scenario 2, P less Q. We know where that region is. We've done that loads of times. Is equal to P intersection Q. Okay, let's do two scenarios. P and Q. P less Q is here. Now, is that equal to P intersection Q? Well, let's do P intersection Q over here. This is P less Q. P intersection Q is in here. So that's not true. It's definitely not always true. It's never sometimes true. So it has to be never true. So never true. The first one was sometimes true. Let's look at scenario 3 now. P intersection Q complement is equal to P complement union Q complement. Okay, let's do two scenarios. So P, let's do P intersection Q complement. P Q. So everything outside P intersection Q is P intersection Q complement. So here and here. And P complement union Q complement. Let's do that here. So P complement is everything outside P, which will be here. And we bring that together with everything outside of Q. I'm just going to label them P and Q. That would be that over there. So yes, that's definitely always true. So we had a sometimes, a never, and an always. So let's look at scenario 4. And there were 15 marks for this question. So scenario 4, P union Q intersection or P, Q, or. So we have 3 sets here. P, Q, and or. P, Q, or. Let's do that again. P, Q, or. P, Q, and or. So the left hand side, P union. So we're bringing P together. So we have the union P, which is all of this guy, with Q intersection or. That should have been an or. P, Q, or. So P union, I have P, I have the union Q intersection or. Well, Q intersection or, if I color it in fully, will be that guy. So now I have all of this guy here, P with that guy. So the one on the right is going to be P union Q. Okay, P union Q. I'll just do 2 lines here. Where does that cross over with P union or? Well, let me actually just do another line there and there. So change color. That's P union Q. So where does that intersect with P union or? This is P union or. So where do these 2 things intersect? And it's probably easier to see that they don't intersect. My diagram's not great there and there, but they do intersect in the rest, which actually leaves us with the same thing, doesn't it? So that is always true based on our scenario. So we had a sometimes and 2 always, and a never for part 2, and the 5 marks for part B, which gave 15 in total, was just to prove this statement 1, but we've shown all 4 here in question 13. And this is how part B looked. Justify your answer, but look, I don't think you can do this question without justifying it, so please justify it in the exam. Don't try and guess. Take extra paper if you need and draw those sets out. And lastly, question 14, literally 8, greater than 8%, I think about 8 1/3%, 25 marks in total for 8 part B. Use factors to simplify. You should see that the bottom is the difference of 2 squares, which is going to be n minus 3 by n plus 3. If you can't see that, you're not going to guess this question. You have to know your factorization. 2n squared on top has to be 2n by n, whatever way you choose to factorize, but this is the best way. One of them will cancel with one of them on the bottom, so it looks like it's going to be a 3 here and a 5 here to give 15. We want to make up a plus n, so we're going to have plus 3 by 2n plus 6n minus 5n. So the n plus 3's cancel, leaving us with 2n minus 5 over n minus 3. I think it looks neater in a bracket. So nice 15 marks for this one, can you believe it? And then part B. A question they're trying to make look complicated, but it's not really. For all values a and b, x is an element of real numbers. X plus a by x plus b is equal to this guy, x squared, plus the sum of the roots times x plus the product of the roots, which we'll go into in more detail again. Using this factor otherwise, answer the following 2 questions. Solve each of the following equation in x, where a and b are constants, and give each answer in terms of a and b. You can see in the box down here, x is equal to 2 answers. Now, this is what's given to us up above. If you notice, this guy and that guy are the same. So this guy is equal to x plus a by x plus b, and it's equal to 0. So my solutions are x is equal to minus a, or x is equal to minus b if you know your rules straight away, or you could say x plus a equals 0, x equals minus a. Or you could give them random numbers, x plus 6. If it was x plus 6 by x minus 5, how would your solutions look? We'd have a minus 6 and a plus 5. They just change. So it's really just your knowledge of solving quadratics here. They dress it up into these kind of constants a and b to try and make it look a little bit more difficult. And there was 10 marks for this guy. Simplify this whole expression. Now we're also given the same thing again, which is x plus a by x plus b, the left hand side. If we divide that by x plus a, you can see that we're just going to be left with x, or just a. Sorry, that should be an x, not an a, as you're all seeing. So we're just left with x plus b. And that concludes 2018 paper 1.